Is I plugged in 1 for y in this equation, negative 2 for y in this one, 8 for y in this. Then I put 1 in for these x's, 0 in for these x's, and 2 in for my last set of x's. So I'm taking my basic form, y equals ax squared plus bx plus c, and I'm creating 3 new equations by putting in the x's and the y's from all 3 of these points. Does that make sense? Where they all went?
I have a question.
You know, one time I tried to teach this by drawing arrows, and it really didn't help.
Oh, that would have.
So I even tried different colors. It was chalk, and it was, you know, this x went here, this y went here, and I thought that would help when someone asked me a question like that, and it really didn't. So, yes, Nimi.
What's the difference between that one and like the way you set up for that one and the difference between the setup with Kramer's rule?
Okay. Here, let me finish this one and rearrange this a little bit, okay? Now, for Kramer's rule, we're used to seeing the linear equations in what's called standard form for them, which would look something like, if I rewrite the equations down here, this is 1a.
But we never had A and B and C.
No, you had x, y, and z, but it's the same principle. This would be 1a plus 1b plus c equals 1. I figured out what 1 squared is, what 1 times b is, and I put the equals 1 on the other side. This one would be 0a plus 0b plus c equals negative 2. And this one would be 4a plus 2b plus c equals 8.
Didn't we used to look at things that were like 2x squared plus 3x plus 5, and then we would plug it in for Kramer's rule?
Not with x squared, no. It was x plus y plus z. There were no exponents. I mean, the exponent was 1, but
Maybe that's what.
yeah, that's what we did with Kramer's rule. We didn't plot any exponents for that. Yes, man, did you have a question?
I don't know.
Okay, no, if you do, it's fine. All right, now, at this point, this is the point where, with Kramer's rule, you would make 6 different matrices, right, in the fractions? The 3 on top and the 3 on the bottom. There is something faster. If you take out your TI-83s, I'll show it to you. If you don't have a TI-83, look on with someone or take really good notes, and I'll try to write out the steps, but some of you may have to help me double check where the buttons are.
Hold your desk.
Hey, Laura.
Okay.
How much more time do we
There is a button on your calculator which performs an operation called...
I'm getting so mad at you.
All right, guys, come on. That is row
Let's just write that.
reduced form. Yes, write this down. Row reduced form. Now, for row reduced form, for a 3-dimensional system, 3 equations, 3 variables, okay? You're going to start with step 1 by creating a, the rows and columns, right, 3 by 4 matrix, okay? You're going to start by creating a 3 by 4 matrix. Now picture what that looks like. Up and down 3 rows, across 4 columns, okay? And what you're going to do, all in one matrix, not yet. Well, give me a minute to show. Let me show you first, and I'll show it in the calculator. But for our purposes, this matrix is going to be the coefficients and what they equal all in each row. So we'll put all our information into one calculation. So this is going to be 1a plus 1b plus 1c equals 1 will be represented by the top row.
Wait, where did you get the equation?
The coefficients of the first equation. That's why I was pointing to them, but you're still right. You were writing them. Sorry. So I'm getting the coefficients of the first a, b, and c. Okay? So for the second row, I'm going to put 0a plus 0b plus 1c, and that equals negative 2. And who can tell me what the last row will look like?
Oh!
4, 2.
Mimi, yes.
4,
Uh-huh.
2, 1, 8. Oh,
4, 2, 1, 8.
Do that whole thing first.
Yeah. So you put this in one matrix. And this will actually give you all the answers in one matrix operation. So there's 17 different ways to solve linear systems. I did not give you the shortest way last semester, but I didn't give you the longest way either. Gave you about the...
Is this the shortest way?
I think this is the absolute shortest way when you got a calculator in your hand, yes. You see, you guys remember linear combinations where you would multiply a row all by a number and try and make variables disappear by adding and subtracting the equations? What happens is some people actually found it faster to write it to do that in this form so they didn't have to write the A's, B's, and C's or X's, Y's, and Z's. So they invented this method called row-reduced form, this series of operations that used to be performed by hand, and you would never do it for 2 dimensions, for X plus Y. But these were guys who were starting to figure out the uses of solving equations with 6 or 7 or 8 variables in them. And then somebody very smart figured out how to teach your TI-83 how to do it. So now, everyone with a calculator, second matrix, edit A. Second matrix, edit A.
We were not supposed to do this.
No, now you are. So that's why I just said everyone with a calculator.
I can't
It's okay.
edit it.
You move the buttons over
No,
to the edit.
I did, but it won't let me move over to the A.
You should be on the A. The A shouldn't require you to move up or down.
I'm trying to change the 3 by 4.
You don't move directly.
No, you don't do directly. You hit enter from there.
Oh.
And then you edit it in that mode. So yes, after you get to A, thank you. I should put this instruction up here. Enter. Okay? Now, what you need to do, you hit 3, enter, by 4. I'm not going to write all the enters, please, if you don't mind. So after you hit these buttons, second matrix, edit A, enter.
Plug it